Hey there. So far, we've introduced an Express server that will allow an individual miner to interact with their blockchain instance. But the API we created will mainly be used for local interaction. The goal is to have a large network where multiple miners are communicating with each other. Certainly, multiple servers could communicate by sending these HTTP calls to each other, but this approach isn't exactly the most scalable since each node would have to maintain a list of all the other addresses in the network. So instead, to achieve server-to-server communication, we're going to take advantage of what is called the Pubsub pattern. Short for publisher-subscriber, this networking pattern centers around the concept of various messaging channels. These channels carry information from end to end. The messages themselves on these channels are sent by publishers. The publishers don't worry about who is really looking at the channel. All they care about is successfully broadcasting a message onto the channel itself. It's up to subscribers to stay aware and look out for any messages that have been broadcasted to the channel they're listening to. They're not worried about who specifically sent the message. The extent of their concern is that there is a new message in the first place. This networking pattern is very scalable. There can be a plethora of channels available in the network, but a subscriber can designate to listen to a subset of those channels, maybe 2 or 3 in the network. Likewise, a publisher only needs to be concerned about broadcasting messages to the channels that it actually cares about. The publisher is intentional in broadcasting crafted messages to maybe 2 or 3 select channels in the network. Therefore, this system requires very little overhead. It reduces a lot of the work needed for alternative networking implementations, like keeping track of socket addresses, for example. In this implementation, real-time socket connections are open between servers, and each server has to maintain a complete list of all the peers it has made real-time socket connections with. Whenever a message broadcast needs to occur between all the peers, the node would need to send a direct message to every single peer that it has kept track of in its list. This is a huge amount of work and overhead. But if this network is sending the same message to all the sockets in the overall network anyway, it doesn't really need a targeting messaging capability that is this powerful. All it needs is to broadcast in general. So it's far more straightforward for the node to generically broadcast their message like they would in the Pubsub implementation. And then any concerned subscriber can handle that message and use it. Applied to our blockchain, we're going to create a blockchain Pubsub network with a few channels. We'll start with the block channel. This channel will exist as a connection between all the blockchain nodes in the network. Then, when an individual blockchain in the network adds a new block to its local blockchain, it will also publish its block data to the channel itself. The block data will be contained in a message, and this allows the other nodes to receive that information since they're all subscribed to the same block channel. Therefore, they'll pick up that message of the updated block, and they can update their own local blockchain instances accordingly. All right, with that, let's move on to implementing the Pubsub pattern to enable real-time messaging between the multiple nodes that we're going to have in our blockchain network.